Hello everyone, welcome back. Myself Rahul. Today we are going to solve a problem related to recursion. So the problem name is word break. So it's very simple problem. Let's go through the problem statement. Here we are given a string S and a dictionary of strings, word dictionary. We have to return true if S can be segmented into space separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. So if we are given a string called suppose Leetcode, and there is one dictionary is also given with the strings as leet and code. So we just basically need to check whether the given string can be formed using the words present in the dictionary. So like leet is present in the dictionary, code is also present in the dictionary. So we have to return true in this case. The other example can be apple, pen, apple. So apple is also present in the string. Then if I see PE and pen is present, then apple again is also present. So here as well we will return true. Right. So we have to see like whatever there can be multiple combinations, but if there exists some order in the word dictionary based on which like if our complete string gets covered, right? If it gets completely covered, then we have to return true. Otherwise, we have to return false. Right, so I guess the problem statement is clear. So I will try to explain how recursion can be used in this problem with an example. So let me take an example over here. So let's suppose the string is a p p e n a p p, right? And yeah, so let's take an example. String is uh, a p p uh, E N A P, right? So this is the given string to us. And what is the word dictionary given to us? Let's suppose the dictionary given is P. P is one of the words. Then A P P E, and pen is one of the words, and AP is one of the words, right? So are we able to compute this whole string using these words in the dictionary? We have to basically check that, right? So first word is P. So if we go via this A P P E, so it is present, but NAAP, like till this part it is present, but uh, NaH is not present. But if we take instead of APPE, if I take just suppose first two characters AP, then PEN, yeah, still here as well, like I'm not able to cover AAP, right? So here I will be returning false. So like how the recursion will come into this picture problem is I will try to draw a recursion tree. So if we are given a string a p p e n a p, right? So we have to tell whether we are able to construct this whole string using the words in the dictionary or not. So this length is 1 2 3 4 5 6 7 8, right? The length of this string is 8. So it can be the case that like if we draw recursion, so it can be that like we take the first 7 characters and one after that one character separately. So it can be that like we are taking 7 plus 1 characters, like we are creating the first 7 characters string first and the other last character separately, right? So if we are somehow able to construct this string and this string separately, then both of these would be returning true to the original string, and finally we would be able to create the original string, right? So if we are able to create this string independently, then obviously we would be able to create the actual string independently, correct? So this is one way of breaking this problem. The other tree that we can create over here is like instead of 7 plus 1, I distributed 6 plus 2. So I take the first 6 characters A, P, P, N, A. These are the 6 characters and other 2 characters AP separately. Right. So if we are somehow able to create A, P, P, N, A from this from the words present in the dictionary, and I'm able to create AP as well using the words in the dictionary, then both of these will be returning true, and finally I will be able to create the original string. Right, so this is one part of the recursion tree. This is the separate part of the recursion tree. Similarly, I have break down into 6 plus 3. If I use first three characters, first five, and then 3. Right, so if I use first five, A, P, P, E, N, so this is one string, and the other string would be A, A, P. So for this string to be returning true, both of these has to be returned as true, which means this string has to be constructed independently using the words in the dictionary, and also this string as well. Right. So let's go down a bit in the same recursion tree. So suppose we are at this part of the recursion tree. We further, so this length is 7. So if 7 can be further break down into 6 plus 1. Right. So here the string would be A, P, P, and A. And the other part would be A. This is one recursion tree. Similarly for this, it will be 5 plus 2. Similarly, it will be 4 plus 3. Right. So there will be multiple recursion trees created over here. So one thing we have to notice over here is, like, firstly, like this, actually this tree would also be further distributed. Like this length is 6, right? So we can distribute it in 5 plus 1, 4 plus 2, 3 plus 3. But one thing to note over here is when we are distributing this, right? So this problem statement A, P, P, and A. APPNA, this statement, this substring is also present over here. So somehow, suppose like we are able to solve for this recursive tree, and it has finally returned false to the original string, and then we are going to the second part of the recursion, which is this branch. Like this branch is already solved, we are coming to this branch, right? So here as well we are again computing whether this string is present in the uh, word dictionary or not. So here we would be recomputing what was already computed over here. So that's why it's kind of overlapping sub problems. So like the sub problems are overlapping, like whatever we have computed in the past, can it somehow be used in the future as well? So that's why this recursion can be converted, this problem of recursion can be converted to a DP problem, right? So that's where the our using the DP solution comes into picture. So that's where we develop the intuition of using dynamic programming. All right, so now like we are a bit clear like why we have to switch from recursion to a memorization approach. Like let's see like what thing we have to memorize basically. Right, so suppose we are given a string A, P, P, E. Let's take this example only. Right, so we have to tell whether this string can be created using the words in this dictionary or not. Right. So if we somehow break this string into two substrings, suppose this is the string and I break it over here, right? So what I need to do is I need to see whether this substring was present in the word dictionary or not, and also whether this dictionary was whether this substring was present in the dictionary or not, right? If both of them were present, then only I will be returning true. Right, if even one of them can't be created the words in the dictionary, then I have to return false. So can I start like can I use a bottom up method, bottom up approach over here, in which like if I have to create a string of length x, then if I somehow know all the substrings, like status of all the substrings whose length is less than x, whether they can be created using the words in the dictionary or not. So let me like I'm going to create one array of the same length as that of string. So here the length of the string is 3 4 5 6 7 8 8, right? 2 3 4 5 6 7, length is 8, so the array length is 7, right? So this is the extra space that I'm going to use. So uh, the value at a particular index in this new array is going to denote whether a string, the input string, can be created till this particular index. So suppose I am at a ith index, suppose I is 2, which, so this index is going to tell me whether I can create a string from 0th index to 2nd index using the words in the dictionary. So I'm going to start from the 0th index. So 0th index just contain A. So whether A is present in the dictionary or not, no, it is not. So I'm going to mark it as 0. Then I comes at index 1. So string present between 0 to 1 would be AP. So I will see whether AP is present in the word dictionary or not. Yes, it is present, then I am going to mark it as 1. 1 denotes that string present between 0 to ith index is present or can be constructed using the words in the dictionary. Then I am going to the 2nd index. The string would be APP, right? So whether APP is present, no, it is not. Then what I need to do over here is I need to see, like, here the, so here suppose my I is at this particular index and I have already know the status till this point of time, right, using this TP array. So my new index is at this particular P. So firstly I see whether the new string APP is present in the input array or not, or word dictionary or not. It is not present, then not an issue. What I am going to do over here is I will create one variable called j, which will be initialized to this index only. And firstly I will see whether a string present between 0 to j is present in the word dictionary or not. So string present between 0 to j is APP only. So APP is not present in the word dictionary, then it is not an issue. Then I'm going to decrement j by 1. So j will come over here. So I will see again whether string is present between 0 to j, which will be a of AP. So whether AP is present in this word dictionary or not. So for that I don't need to again look into the word dictionary. I can reuse the new TP array which I had created using this index, because this index was denoting whether AP string can be constructed using the word dictionary or not, right? So basically we are reusing whatever we had stored earlier. So AP was value 1, right? So I am able to construct a string AP, and right, so I had gone basically 0, j is over here, I minus 1. So 0 to I minus 1 has been covered. Then I need to cover, basically 0 to j has been covered. Then I need to cover j, string between j to I as well, right? So string between j to I is just p. So p is also present in the word dictionary, right? So it will return true. So I am returning basically true from both the places. So I will mark this also as 1. I hope this step is clear, right? Then I am going to increment I. I will move over here. I am going to check whether APP is present in the word dictionary or not. Yes, it is present. Then I am going to mark it as 1. Then I am going to see APPEN. Then I moves over here. So APPEN, right? So I is over here. So this whole string is not present in the word dictionary, then not an issue. I will create one variable called j, which will be initialized to this particular index, and I'm going to see whether a string is present between 0 to j in the word dictionary or not. It is not present, then I am going to decrement j. J will come out to over here. So string between 0 to j would be a ppe, right? So this string, whether this string is present in the word dictionary or not, we don't need to look into the word dictionary again. We can again reuse whatever values we had populated. So this value over here, 1, is basically denoting whether APPE can be constructed using the word dictionary or not. So it will return true. So string between 0 to j is APPE, so it has returned 1. But string between j to I, which is nothing but string n, it is not present in the word dictionary, so it will return 0. So 1 and 0, if I take the AND of that, it will give me 0. So I will populate 0 over here. So in this way I am going to populate my DP array, and Whatever the value of my last index is, it will tell me whether the whole string can be constructed using the words dictionary or not. Right, I hope the solution is clear. So I had already written the code for this. I will try to explain the step by step. Yeah. So here we are given a words dictionary and a string s. So instead of always checking in the word dictionary whether a word is present in this dictionary or not, I've created a set in which I'm going to insert this word dictionary elements, strings, so that the lookup time doesn't come out to be the size of the word dictionary. On an average basis, if I look a string into the unordered set, it would come out to be of 1. Right, so this is a string, and in this is a set, and in this set I am just inserting all the elements present in my dictionary. Then I'm going to iterate over each individual index like one by one, and I'm initializing one variable j, which is nothing but the current index only. Right, and I'm going to do this process till j is greater than 0. So I had told you that like I will be decrementing j. Right, so the decrement operation has to be done till the point j is greater than 0. Right, and one check I put over here is if I is equal to j, which means like I have initialized j as I only. So if j is equal to I, which means that basically I need to check the complete string into the word dictionary. Right, so here I'm checking st dot find whatever the string is present between 0 to j plus 1th length. So substr is the stl provided in the string. So this is the first argument in this substr function denotes the starting index of the search, and the second argument here denotes the length of the string. So I'm going to start from the 0th index, and the length of the string to be considered is j plus 1. Right, so in that way I will be reaching jth index if I start from the 0th index. If it was 1 over here, then I could have just placed j over here, but it is starting from the 0th index, then that's why I have to put j plus 1. So I'm just checking whether this string is present in the already defined set is nothing but the new version of word dictionary. So if it is present, then in that case I'm marking the new created dp array for that particular index as 1, and I can break the while loop from that particular point. Right, if I is not equal to j, which means uh, that this complete string is not present in the word dictionary, I need to decrement j somehow. Right, so firstly I need to see whether the dp of j, like I had already decremented j by 1 over here. So if I was initially equal to j and this if condition wasn't executed, then I would have reached over here and j would have decremented. Right, so if this is the string, I is over here and j would have been one value less than I. So this else if condition would have been executed, and I would be checking whether dp of j is 1 or not. dp of j equal to 1 denotes that uh, that the substring between substring 0 to jth index can be constructed using dictionary words if this is equal to 1. But if it is not equal to 1, which means the substring present between 0 to j can't be constructed using the words dictionary. Right, so suppose if we can construct a string between 0 to jth index, so we also need to check the remaining substring which is present between the j to I. So that's what we are doing over here, st dot find, and in that case like we are updating the dp of I is equal to 1, and if both of these conditions are valid, then I'm marking dp of I equal to 1 and breaking the while loop. Right, and if we have reached the starting of the array and till this point the dp of I hasn't been marked as 1, then I can just mark dp of I as 0, which means that substring cannot be created using the words in the dictionary. Right, so finally I have to basically return the last value present in the dp array. S dot size minus 1 denotes the last index. Right, so I will run this code. Yeah, I will remove this cout statement. Yeah, runtime and memory usage are also fine. So like it was a very good problem related to DP and recursion. So I will recommend you to draw the recursion tree that I have drawn over here and try to understand where we are generating the overlapping subproblems and why do we need to specifically jump to the DP part, dynamic programming part. Because like here we have overlapping subproblems, and if we somehow maintain the results that we have already solved for, then we can somehow use those subproblems in the coming calculation of the greater problem, right? So I guess, yeah, you are clear with the solution. So for this, the time complexity would be like if we are at a particular index, we are going through all the previous indexes. So the time complexity for this would be of n square. The space complexity would be of n only. So time is of n square and space is of n, right? I guess this is the optimized solution, and if you guys have any better approach to this problem, please do comment. And I hope the solution is clear, and if you haven't subscribed to the channel, please do, and I will see you next time with another problem. Thank you everyone.